A local animal shelter receives at least 4 cats and 7 dogs a day. The shelter has the capacity to receive up to 30 cats and dogs a day. If the shelter can raise donations at a rate of $3 per cat and $5 per dog per day, how many dogs and how many cats should the shelter accept to maximize the amount of the donations per day? So first of all, we want to find a function that represents our donations, which I'll call D. We know that they get $3 per cat and $5 per dog. So let's let lowercase c represent the number of cats and lowercase d represent the number of dogs. Then their donations are going to be 3 times c plus 5 times d. This is the function that we're trying to maximize. What are our constraints? It says the local animal shelter receives at least 4 cats and 7 dogs a day. So that means that C is at least 4, so that means greater than or equal to 4. And D, the number of dogs, is at least 7, so that's greater than or equal to 7. We also know that the shelter has the capacity to receive up to 30 cats and dogs. That's the total that they can accept. So that means we have another constraint that C plus D must be less than or equal to 30 because they cannot accept more than 30 total. So we have our function that we're trying to maximize, and we have our constraints. So let's draw the graph. All right, C we'll put on the horizontal axis, and D we'll put on the vertical axis. So C must be greater than or equal to 4. So if C must be greater than or equal to 4, again, I'm not going to draw this to scale, but greater than or equal to 4 would be over here to the right of 4. D needs to be greater than or equal to 7. And so D would have to be above this horizontal line here, where D is equal to 7. And then finally, our other constraint that C plus D must equal 30. We can see that the intercepts here, if C is equal to 0, D will be 30. And if D is equal to 0, C will be 30. And our line goes through these 2 points. Looks something like this. All right, so our region then that we're looking at here, according to our constraints, is within this little triangle right here. We need to find the vertices of this triangle. This vertex here is when C is equal to 4 and D is equal to 7. This vertex here is where the line C plus D equals 30 intersects the line D equals 7. So that would mean that C plus 7 is equal to 30. So C would equal 23. So that would be the point 23 and 7. And then finally, this vertex here will be when C is equal to 4, intersects the line C plus D equals 30. So if C is equal to 4, then 4 plus D is equal to 30, and therefore D is equal to 26. So our other vertex then is 4 26. We want to see where our donations are maximum, so we're going to check our capital D at each vertex. So first of all, at the vertex 4, 7, we have 3 times 4 plus 5 times 7, which is equal to 12 plus 35, or 47. At this vertex, we're going to have 3 times 23 plus 5 times 7, which is 69, plus 35, or 104. And then finally, at the last vertex here, we're going to have 3 times 4 plus 5 times 26, which is equal to 12, plus 130, or 142. So we see that the maximum donations is 142. It occurs at the vertex 426. So that means we want 4 cats and 26 dogs to maximize the donations.